All right, I think you're ready to begin.
Okay. Oh, well, hi everybody. My name's Amanda. Here's my face really quick so that you can see me behind my mask. There's not anybody in my immediate area right now, so I'll just take that off for a minute. I'm an interpretive park ranger here at Dinosaur National Monument. So my normal job is doing education programs. I don't get to talk to college classes all that often, so it's kind of a fun change for me. Usually I'm doing like 2nd to 4th grade classes. So it's quite a different audience, and that makes it fun for me. So we're here in the Quarry exhibit hall in Dinosaur National Monument. Dinosaur National Monument itself is located in both Colorado and Utah. We're currently in Utah, and most of the monument is actually in Colorado though. So it's a little interesting. We span the boundary of both those states. Dinosaur National Monument is about 200,000 acres, and the dinosaurs are really just found in this immediate area. So you get a lot of people who come visit and are looking for dinosaurs throughout the monument, and they're not going to find them because they're really just in this place. So we're going to do a tour of the Quarry exhibit hall today, and I'm going to, in a minute, step back so you can see the building a little bit better and kind of get a perspective of where I'm calling from and what we're talking about. But just want to give you guys kind of a brief overview. So Dinosaur National Monument was established in 1915. And it was first just established to protect these dinosaur fossils. So it was originally just 80 acres just surrounding this area. And then it was expanded in the 1930s to include the river corridors. So hence the name Dinosaur National Monument, and not having a whole lot to do with dinosaurs other than right here. So that's where that is all from. And we're a pretty big national monument. We're actually the 2nd largest national monument that's not yet a national park. There's not really a big difference in a national park and a monument other than just in name. So we're all managed the same. We're all park rangers. We all work through the same National Park Service organization. So that's just a really quick overview. And then I'm going to take you guys over. We're going to take a peek out the window and kind of get into why this is such a unique site and why you guys are on a field trip today. I'm actually going to flip the camera. Hopefully that didn't mess you up too much. And flip you around. So we're actually inside this building. We're going to take a quick peek outside. Like we were kind of talking about before, it is super smoky today, but you can hopefully see some of the rocks outside. This building is also open to the public, so if you see public kind of walking around, we are currently open to the public, and people are kind of in and out all day. So what we're looking at when we look out here, Dinosaur has 23 different rock layers. It's actually the most complete geologic history of any unit in the National Park Service. So there's a lot of time that's displayed here. And all of that primarily is sedimentary rock. We have one really tiny little bit of igneous rock, but it's primarily sedimentary rock. And so you can actually see out here these rock layers that are kind of on this angle going this way. All these rocks, when they were first laid down, were flat, and as the mountains pushed up, as part of the Rocky Mountain uplift, this portion was pushed up as well. So what you're seeing here is really a big anticline, so a big fold right here. And this mountain right here is called Split Mountain, is the top of that fold. You cannot see right now how it actually folds back up this other direction here. So it's kind of doing the anticline and syncline wave together. You just can't really see the rocks super well at the moment. Let's see.
And just on that note, I'm going to point out for the folks who joined us late, because I knew it was smoky today, I pulled up a picture from the park website. So we're looking from a slightly different view. You see the building here, and these are rock layers that are started out flat and they've been tilted up. And you see the beautiful cliff. That's what used to be a flat surface of a river plain, as we'll hear more about that. And it was buried, turned into rocks, tilted when the mountains formed. And I'm gonna turn off my video now that we've seen the outside.
Awesome. So the rock layer we're going to be talking about particularly today is called the Morrison Formation. It was named for where it was first discovered in Morrison, Colorado. And it's basically right behind this like minivan or whatever, the SUV out there. So that layer right there is the one we're going to be talking about. At the time when that rock layer was being formed, it was about 150 million years ago. And this whole area was much warmer and much wetter than it is today. We are also physically closer to the equator, so that helped being warmer. And it was basically a big floodplain like you would think of on the African savanna today. So like kind of periods of drought and then periods of big flooding. And that's where these dinosaurs were living in an area that even didn't have flowering plants yet, because flowering plants had not evolved yet. So that's kind of a fun thing to think about. Would have looked quite a bit different than it does today. But all of that is captured in the rock. And so we know all of that by looking at the rocks and the different fossils that are here. So I'm going to turn this way. So we were just looking out the windows on the side of this building. And I'm going to turn this way so you guys can hopefully get some good perspective of what this building looks like. So this is, again, is the Quarry exhibit hall. This building was built around this wall of rock. And inside the rock wall are, I'll just stop moving so you can hopefully see it a little better. In the wall today, there are approximately 1,500 dinosaur fossils. And we're going to get a closer look at them, but you can probably see some outlines and pieces of them. They're all in the original place that they were found, and we excavated the rock that was over top of them. So you're looking at the original fossils in the place that they were originally found, which is pretty unique. This whole area down here is, if you came to visit, you can actually touch this. We let folks touch this wall right here. And we're actually going to take a walk up on the wall in a little bit so you can see the bones a bit closer. This mural over here is what we think it looked like here about 150 million years ago. This mural was painted in about 2011. So it actually, there's some things that we know now that we didn't know about dinosaurs then. For example, most of the carnivorous dinosaurs would probably have had feathers. So if we were going to do this painting today, we would be adding feathers to all the carnivores. And we can talk more about feathers and dinosaurs and all of that in a bit. We also find other fossils mixed in with the dinosaurs. So here's a fossil of a turtle. And this was also found in the Morrison Formation. And here's a little baby turtle. You can see this cute little guy with his little foot there. And then these are bits from a crocodile. So crocodiles were also living at the same time as the dinosaurs, and we're finding their bits and pieces mixed in with the dinosaur fossils as well. So the reason there's so many dinosaur fossils in one place here today is because of those periods of drought and flood. So during a drought, most of these dinosaurs may have come to the water, not found any, and died. They may have died from the drought directly, or from the lack of rain causing the plants to die, and then they died that way. It's really hard for us to tell how any individual dinosaur died, but we can assume that they died from this drought. And then eventually the water came back and washed all those fossils downstream and pushed them into a big jumble. So that's the reason there are so many dinosaur fossils here today, and why there are all these kind of bits and pieces of different dinosaurs all mixed together, because of that river environment washing them, just kind of washing them downstream. Would have been a really big river, so think the size of the Mississippi River today. So really big river, able to move these large dinosaur fossils or bones at the time. All right. So you wanted to go look at the Allosaurus first, yeah?
Yes, please.
All right. Let's take a walk in here. Okay. We're just kind of walking around through the museum. In here, we have a couple of different displays that I can show you guys. So this one, I'm going to try to get the whole thing in here for you. This is a cast replica of the Allosaurus jamadsoni. So Allosaurus was one of the dinosaurs found here in the quarry, and the species that's found here in the quarry is called Allosaurus fragilis. It's about 151 million years old. And this Allosaurus jamadsoni is estimated to be about 5 million years younger, or I'm sorry, older than the Allosaurus fragilis. So the Allosaurus jamadsoni that we're looking at right now was not found in the quarry. It was found in a different area in the Morrison Formation. This particular fossil it's a really incredible fossil because it's articulated, so you're able to see kind of all its pieces put together in a lifelike position. And they were also able to find its skull. The skull is really unique because you can see essentially like the inside of the skull from one side, and then they actually prepared like around the back of this, they prepared the other side as well, so you can see both sides of its skull. So here's what the other side looks like. This Allosaurus fossil, so these are both replicas. The original Allosaurus is in our museum collections. So we have that specimen here.
And could you show us a close-up of the skull and the slab again?
Oh, this one over here? Sure.
Yeah, there are two things I wanted people to know.
Yeah, the light is a little hard, so I'm gonna...
Yeah, well, specifically the teeth.
Yeah.
It looks to me like you got a gap there and there's a little tooth coming in. I'm gonna just point out that dinosaurs were constantly replacing their teeth. So unlike mammals, which only have 2 sets of teeth during our life, dinosaurs and other reptiles are kind of like sharks in that they're constantly wearing down their teeth and getting a new one. And their teeth are approximately all the same shape, so it doesn't matter when one falls out, they just grow a new one in.
Yeah. And we can look at this one over here too. When we're looking at the other Allosaurus skull we have here, we can also point that out too. So you can see the different teeth lengths and all the same shapes.
Yeah, that's awesome.
Yeah, if you'd like, remind me when we're back at the wall, and I can actually show you an Allosaurus tooth that's embedded in the wall still.
Awesome.
Yeah, so it's more common to find dinosaur teeth than really any other dinosaur fossil, because they were constantly regrowing them. There's more opportunities to find dinosaur teeth than there is like a dinosaur femur, because they would only have one after they died.
And there was a question that somebody had submitted wondering how long it takes to prepare a fossil, and this one, you had mentioned it was found a while ago. Would you say a little bit about that?
Yeah, so this fossil was found in the 1990s, the early 1990s. It takes a long time not only to prepare a fossil, but also to compare it to other dinosaurs. So this Allosaurus jamadsoni was in the news recently as being a new dinosaur, but it was found in the 90s. So like what is the deal with that? And basically it took a long time for scientists to prepare the fossil and compare it to other specimens to actually figure out it was a new species of dinosaur. So that paper was published recently, and just in the last year or so. And so it's come out as a new species of dinosaur, where it was really just discovered in the 90s. As far as preparing a fossil, it depends a lot on the rock type it's found in. So the matrix, like what this is like, on how hard that is. So that has a lot to do with it. And how big the fossil is also has a lot to do with it. This is a great example of, if you were preparing this fossil, sometimes it's hard to figure out, like, if you want to get to like a bone under here, then you would have to prepare all the stuff on top of it to get to that as well. So the time can really vary based on size and position of the different fossils. So anywhere from just a couple months to several years, depending on the process and the weather and the rock it's in. So a lot of factors go into how long it takes to prepare a fossil. Yeah. Any other questions about the Allosaurus jamadsoni before we go back?
I'm going to ask you just one more thing. He's got the end of his tail there, and that's just such an amazing thing to find. I want people to look. We see these as we get in a little bit closer. Yeah, the lights, I know.
Yeah.
But each of those lumps is a vertebra in the tail, and if you go on up, briefly, it's fuzzy, I know, but just
Let's
look
see
at
if I can, yeah.
how small those are. I mean, they're the size of your fingers, and they're almost
Here.
always lost for
You
dinosaurs.
can see how big that is.
Yeah.
With my hand. Yep.
So the length estimates for a lot of dinosaurs, we just have to guess how big their tails are because those little bones are gone. So just something to keep in mind when we talk about how long dinosaurs are is often we just don't know.
Yeah, great point. Anybody, if you have questions about the Allosaurus, you can put them in the chat. If not, we'll go and talk about some other stuff.
Yeah, let's see what you got, and we'll see, as people think about it, what comes up in the chat.
Yeah, and we can also come back over here too, like if you think of something later and want to put it in the chat, we are going to have quite a chunk of time for question and answer at the end of this as well. All right. So if you don't have anything else, we're going to take a walk back over here. So what I like to talk about next is kind of just what is a fossil. So I'll pose that question to you guys as I did yesterday, but I will do it to you as well. Like, what is a fossil? What does that mean to you?
I'm going to encourage everybody, just put something in the chat. Let's see what range of ideas we have.
Make sure you're not sleeping. Anyway. Okay, so still wait. I see one answer that's come in. Anybody else have a thought on what a fossil is? Seems like a pretty basic question, but there's a lot of layers to that. Nice. Okay, seeing some answers here. Awesome. Great. So I'm seeing some good answers coming in. They're like bones, yeah. A story from the past, preserved remains, something that is preserved over time. Evidence of life. I think you guys were here yesterday, so awesome that you already know my answer to what is a fossil. And thank you guys for participating there. So a fossil, yeah, is really any sign of ancient life. So it can be very broad. It can be a bone, it could be a footprint, it could be a coprolite, which is fossilized poop, which always gets a laugh out of fourth graders. But those different kinds of things are basically showing us any evidence of ancient life. How old does a fossil have to be is kind of this gray area, because when something actually becomes fossilized, it's going through a chemical process to do that. So I'm just going to do a brief kind of overview of that. If you were here yesterday, I apologize. We're going to review. So for something to become a fossil, in this process, the type of fossilization we're talking about, or I'm going to talk about right now, is called permineralization. Basically, the fossil itself, the bone is getting fossilized. So that's the type of fossilization we're going to talk about right now. So first thing for that, you need some kind of evidence of life. In this case, a bone. This is a cow femur. So this is a bone, not a fossil. And there is a pretty big difference between those two. So again, I'm going to try, if you guys can see the spongy part, that is inside of the bone. Okay. So there's a smooth outside on the bone, spongy inside. And this is where like the blood and bone marrow is inside our bones. Inside cow bones, inside dinosaur bones, it's all the same thing. And essentially the inside is porous and hollow. So for something to become a fossil, basically those empty spaces have to be filled in. So there's essentially 3 steps to becoming a fossil. The first step is something has to die, right? So it was alive and it has to die. And that's how we're getting the bone from. The second step is it has to be buried in something, usually in some kind of water is how that would happen. So it's getting buried. And then the third step is time. Okay. So it has to stay buried, basically. And what happens is that spongy part, when it gets buried, starts to fill in with mud and water. And then over a long time, if it stays buried, that mud essentially turns into rock and exchanges chemicals and minerals with the bone itself. So then you get a fossil, which this is a tailbone from a sauropod or a long neck dinosaur. And you guys can see maybe this orange stuff right here. So that is the same thing we were just looking at, the porous inside that's now been filled in with mud, and that mud turned into rock. Okay. So just to review, 3 steps to becoming a fossil. 1, something has to be alive and it has to die. 2, it has to be buried. And 3, it has to stay buried for a long time. And we're talking several million years to become a fossil. Okay. The other really big difference that you can tell right away, you guys can't tell from here, but this is very heavy. And the reason for that, like this is a really dense chunk of fossil because that mud that turns into rock like fills in those empty spaces, and the fossils themselves get much heavier than their equivalent bone would be. So this is much heavier than this bone right here. So kind of fun thing to think about when you go to like a museum and you're wondering if something is a fossil or if it's a replica. A good way to tell right away is if it has metal holding it up, right? So if it has metal holding it up, it's probably the real fossil because those fossils are so heavy, right? If it's something that's in kind of a dynamic, lifelike pose and you don't see any metal, it's probably a replica, some kind of plastic, because the actual fossils themselves are so heavy. Any questions about that at all? I saw a couple things come through in the chat. All right. Is there a museum for fossils of Neanderthals or ancient humans? So that's kind of an interesting question. Like that goes back to like, yeah, and Catherine's answering that too. So it kind of goes back to an interesting like, are human remains fossilized? Like our mammoth fossilized? Or like mammoth and mastodon bone? Those are actually bones, not fossils, because they haven't gone through the process we just described. So that's kind of an interesting thing to think about. It's like they haven't had enough time to become an actual fossil as defined that way. But if we're thinking of a fossil of any sign of ancient life, then it would be. So I know that's kind of one and the same, but something to think about there. All right. Any questions?
I'll just add, since you had mentioned it, since mammoth and other ice age animals haven't been fossilized, what that means is that they have their original tooth enamel, their original bone. Sometimes you even have bone organic matter inside, though that's more rare. Teeth particularly are well preserved. You can grind them up and analyze the chemistry and figure out where they were migrating, what they were eating, what the climate was like. And that is what I actually did for my dissertation. Nice. So fun to have that mentioned.
Yeah, there's a lot you can find out for sure.
Unfortunately, it's really hard to do that with dinosaurs though, because they've all been altered.
Mm-hmm. Yeah, and then the next question a lot of people ask when they're visiting here is like, well, can we find dinosaur DNA, right? Is that a thing? Can Jurassic Park be a thing? And the short answer is no. That's why in Jurassic Park they needed like the mosquito and the amber, right? Because when dinosaur bones or dinosaur fossils go through this process, that permineralization process, basically there's like any soft organic tissue, like any carbon stuff, any DNA is all gone. So the original organic material that's still left in the fossils is just calcium and iron. So it's just like the hard organic materials that would be left. So if anybody finds a mosquito, maybe that could be a way to get Jurassic Park, but we don't have any of that here. Also, DNA decays on the order of thousands of years instead of millions of years. So basically the the fossils are way too old to have any DNA material in them as well. Any questions about that? Awesome. So we're going to take a quick walk over while we're kind of on the topic of dinosaur teeth. I know we talked about that a little bit. I'm going to go, before I forget, show us that dinosaur tooth. So I'm going to put you guys down for just a second. You're going to look at the ceiling. I apologize. So I have to open this little gate, and then we will be able to look at something a little more up close. So, stand by. Okay. So we are, I'm just going to flip you around. So we're going inside this little gate. I just unlocked it. And we're going to get a closer look at some of the fossils. Okay. So this is that section I showed you guys earlier, which has many different bits and pieces of fossils all mixed together. I'm being pretty careful where I'm stepping, actually, because you can see even right by my foot right here, there really are just fossils kind of everywhere you look. So you have to be really careful when you're walking in here, just because there's like all these little bits. And one of those exciting little pieces is right here. Can you guys see that? Yeah, okay. So this is an Allosaurus tooth that you can see right here. And if you actually touch it, you can actually feel the serrations on top of it. So this is likely a tooth that an Allosaurus lost, not one that like died and got washed down, but likely a tooth like we talked about before, how they were regrowing their teeth. And you'll also see the numbers on here. Every single one of the fossils on this wall has a number. That goes with our museum collections. So every single one is numbered and cataloged. We may or may not know what that bone actually belongs to. Like, for example, if you find something like this guy, this has a museum collections number, but I can almost guarantee that we don't know what this is, because it's just basically a little piece, a broken off piece of a fossil. The other thing we might not know, like this is part of a rib, but we may know that's a rib, but just not know what dinosaur it belongs to. So unknown dinosaur, known body part, if that makes sense. The other cool thing I wanted to show you guys while we're in here looking at some of these bones up close is this really special one right here. So these two, this one is a sauropod, aka long neck dinosaur, humerus, so an upper arm from a long neck dinosaur. And this little bone right here, this is actually a femur from a sauropod or a long neck dinosaur. So you might notice that femur seems way too small to be from a sauropod. And you would be correct. This is from a baby sauropod, a baby juvenile long neck dinosaur. And if you look really closely, you can actually see here, these little stripes right here. These are teeth marks on that baby dinosaur femur. So we've had some scientists study this. We think these are Allosaurus teeth marks. We can't tell if they were from before or after the baby dinosaur died, so it's hard to tell if it was scavenged or if it was killed or something like that. Or maybe both. Any questions about that, you guys? Type them in the chat.
Actually, I'll point out, we had one question who was asking what the best way to refer to you. Is it Dinosaur National Park or Dinosaur National Monument?
Oh yeah, sorry, I missed that one. Dinosaur National Monument. Yeah, good question. National Park Service is like the organization, but we're technically a national monument. So good question there. Yeah. How long is the Allosaurus tooth? I just saw that question come in. You can see my finger next to it. I know it's kind of hard because it's like not the best quality it's ever been, but it's probably about an inch or so, maybe an inch and a half So to give some scale there. Yeah, we can talk about feathers a lot in a little bit. I think that's kind of a really interesting topic. So we'll come back to dinosaurs and feathers. Again, if I don't remember, please remind me, because it's a really cool topic to talk about, is how dinosaurs and birds are related. Yeah. All right, would you guys like to climb up on the wall so we can see some fossils a little closer? I'm going to attempt to do this without any other people in the building following me. Oh no, you guys are good. So we're gonna go right up here. I'm gonna shut this gate really quick. Same thing, so I don't get people following me. So we're gonna climb right up here on the wall. I'm gonna try not to make you sick, and look at what I'm doing at the same time. Okay. And on the way, you can get a nice look at this Diplodocus tail. Diplodocus is one of the sauropods. So there's a nice tailbone right here. And so that's where we just were. Down there, you can wave at some folks on the upstairs floor. And we're gonna get a closer look at some of the fossils. Okay, so first we're gonna talk about this one. And we'll see, I know a couple of you were here yesterday, but not a lot. So does anybody have a guess what this bone is? What you think this dinosaur fossil might be? And you can type that in the chat. What do you think this is? I see some people cheating. Awesome. Long, thin, triangular shaped bone. Nailed it. Thagomizer. That's pretty funny. Well done. Yeah, so this is a Stegosaurus tail spike, both for the folks who are cheating and everybody else. Fun story. It's called a Thagomizer kind of as a joke, like affectionately called a Thagomizer, because that actually came from a Far Side cartoon, and the name kind of stuck because there's not really a great name for a Stegosaurus tail spike. So this is, yeah, a tail spike right here from the dinosaur Stegosaurus. And just as a review, that's this little guy right here. He had 4 tail spikes on his back there that he likely used to defend himself. And this is what a tail spike looks like when it's not in the wall. So you can get a little bit of an idea of how big that is. Would have been, it's totally made out of bone, so it would have been a pretty good weapon to help defend him from other dinosaurs in the area. And then this guy, this is a Stegosaurus plate. So Stegosaurus had a bunch of plates. They were all different shapes and sizes. Some were very large, some were kind of pretty small like this one. And but they all were very thin. So I'm gonna turn it this way so you can see how skinny it is. Most people, most paleontologists agree that Stegosaurus likely used his plates for some kind of protection. But after that, the verdict is still out. You can see these little lines on here, which are blood vessels that were in the Stegosaurus's plate. One of the theories is that the Stegosaurus may have been dispersing heat through his plates as a way to stay cool, just like an elephant that's dispersing heat. So that might have been so what he was using them for, or it could have been to have a display, like if he was trying to show off to other dinosaurs, trying to get a girlfriend or something like that. So those are all different ideas about what Stegosaurus uses plates for, but we really just don't know yet. We need more discoveries to try to help us figure it out. Yeah, good question. So Stegosaurus had no feathers. We don't think so, but again, it's one of those interesting things, like we don't know just because we haven't found it yet. So we think that most of the theropods, which are the meat-eating carnivorous dinosaurs, likely had feathers. As far as the other dinosaurs, there's still ongoing research on that. Yeah. So I see some questions coming in. The plate is bone. Yeah, so the plates were hard bone, and that's why they fossilized like that. And they were not directly connected to the backbone of the Stegosaurus. Let's see. What type of questions need answering to determine the use of the scales? Yeah, it's basically like, as we find more and more fossils, we learn more and more. So initially, when Stegosaurus was first discovered, the name Stegosaurus actually means roof lizard, because they thought the plates laid flat on their back, kind of like shingles on a roof instead of upright. Okay, because when they first found Stegosaurus plates, they weren't articulated. They weren't in a lifelike position. So scientists first thought they lay flat instead of kind of up in the air. And it took us finding an articulated specimen put together lifelike position of a Stegosaurus in order to determine that their plates were actually went up in the air. So what we know and what we think we know about dinosaurs changes a lot based on discoveries that are happening. And that can really change over time. Good question. Let's see. Okay, I think that covered kind of all the questions here, unless you guys have other ones that I missed and they're popping up. The last thing we're going to talk about Stegosaurus is his skull. So here is a Stegosaurus skull. I'll turn it this way so you guys can see his teeth a little better. Stegosaurus was an herbivore. He was eating plants that were pretty close to the ground. You can see he didn't have any teeth right in front. I'm also going to turn him this way. He didn't have any teeth right in front, so he probably would have had like a little beak that he could have grazed on plants that were close to the ground. And all these other holes in his skull were from basically like an air sac system, kind of like our sinus system today. His brain would have been right here. This is little Stegosaurus brain would have been right here. Stegosaurus's brain was about the size of a walnut, if you can imagine that, or the size of like a cat's brain today. But Stegosaurus was a much, much larger animal. So we can infer that he wasn't the smartest dinosaur that's ever been, but he didn't really need to think too much, as he was a herbivore dinosaur that didn't need to think about getting plants. All right, any other questions about a Stegosaurus before we move on? Yeah, 1 to 2 tons. Awesome. Great. Okay, so we're gonna take a walk over here. As we're doing that, just kind of taking a minute to look so you guys can really see all the different bones that are mixed in here. Again, because of this river environment, we really do just get this kind of mix of all these different bones that are all mixed and jumbled together. So it's hard to really tell if any individual bones are from the same dinosaurs or not. The only way we can figure that out is if they are articulated, if they're laid together. And also, I realize it seems kind of bright in your screen here, but you can see the glue on here. So there's also glue on a lot of these fossils, kind of holding those delicate parts together.
Yeah, if you could just hold the camera in place for a second, because that's actually an awesome view for us. The darker areas that she was pointing out, looks like that's the glue. We've got the smooth surface of the bone. And could you pull out just a little bit? I can't tell. Is that a scapula? Or...
This one we're looking at, yeah, this is a scapula right here. Yep.
So the shoulder blade. And then next to it, you notice you've got sort of white stripes. That's where people have chipped away at the rocks.
Yeah, interesting kind of fun trivia about the quarry. Especially if you look up here, you can really see a lot of those excavation marks. And when they did the initial excavation, inside this building was from the 1950s to the 1990s. So it's interesting to think about like our views about conservation changing over time. Because these chip marks were actually cosmetic. A lot of them were put in to make the wall look more interesting, and done after the initial excavation.
I wondered about that because they look awfully neat for a...
Yes, yeah. And you can see like they're more at the top of the wall, and then as we kind of work down, they start to go away. Basically, times are changing, and it was a lot of work to do that. So they really kind of phased that out by the 1970s as they were doing work in here. Yeah.
Is there still active excavation? Somebody had asked that.
Yeah, good question. So they finished up excavating this wall in 1992. So that's when they finished that up.
How about
as far
elsewhere?
as active excavation in the monument, our paleontologist right this minute is focused more on museum curation, like things that have come out of this wall and haven't been well studied or cataloged. So we don't have any active excavation right now because that's what she's focused on working on instead of getting more things.
Do you know how many specimens approximately there are in the museum?
That like thousands and thousands. Yeah. Just I don't know because there's literally so many that have not been. Some of them are still in their initial like wrapping, like they were excavated and haven't even been opened up from their like field dressing.
And I'll say actually that's pretty common for museums.
Yeah, for sure. So, but yeah, I would say thousands easily.
Job security for her then.
Yeah, for sure. Yeah, our paleontologist just we've done a lot of work to our museum collection since she's been here she's only been here for about 3 years, so that's been her main focus instead of continuing excavations. Yeah, good question though. All right, so this funky bone that we're looking at right now, and if you were here yesterday, don't guess, but if you were not here yesterday, what do you think this bone might be? That I'm going to touch it right here so you can see how big it is. Any guesses on what you think that might be? This big guy. What do you think? Seeing lower jaw, pelvis, question mark, a face. I like that one. Yeah, awesome. So it does look a lot like a pelvis or a jaw or something kind of weird. This is actually a single neck vertebrae. So if you touch the back of your neck and feel the bump in the back of your neck, that's the same bone here. You're looking at the bottom of it, so that's why it's kind of got this weird shape. So you're looking at essentially from the bottom, and this is where it would have connected to another bone down here. But yeah, just one neck vertebrae. And that belonged to a dinosaur called Apatosaurus, which I'll grab my little toy here. Apatosaurus is this dinosaur. Okay. So this is just one neck vertebrae that we're looking at. Apatosaurus was a massive dinosaur, approximately the size of 5 elephants. So just this really, really monstrous, massive dinosaur. Apatosaurus is the same dinosaur as Brontosaurus. So if you know Brontosaurus from growing up with that, Apatosaurus and Brontosaurus are actually the same thing. Quick explanation of that. Basically, when scientists were first discovering dinosaurs in the late 1800s, they were essentially racing to see who could name as many dinosaurs as possible. And some questionable science happening because they were just kind of trying to basically race each other to discover as many dinosaurs as they could. So one scientist found bones from a Apatosaurus, moved along. One scientist found bones from a Brontosaurus, moved along, and didn't really compare to realize they were the same dinosaur. They also never found a skull for a Brontosaurus until just recently. So it wasn't incredibly obvious that they were the same dinosaur. And then when that was figured out in the 1990s, they went to the earlier name, which is Apatosaurus, even though most people don't know that one. Yeah. Any questions about that? I saw some chats come in. Just double check, see what's going on. Yeah. Maybe you guys will talk about the bone wars in class. I feel like that's kind of a a thing that probably will come up, but we'll see.
We just finished talking about that last week. So
awesome. Yeah, so this is a perfect example of that. Great.
But as I remember, this particular quarry wasn't found until the early 1900s.
That's correct. Yeah, so the Apatosaurus was not first described here.
Right. But do you remind me again when the first dinosaur was found at this site?
Oh, 1909.
Okay.
Yeah, so a little after that, the Bone Wars time period.
Yeah.
Awesome. All right, so the last dinosaur we're going to specifically talk about is this one here. This little guy, which is the Allosaurus. So a lot of people think this looks like a T-Rex or it looks like a Velociraptor. Allosaurus was around about 150 million years ago. So not the time that a T-Rex or a Velociraptor was around. T-Rex and Velociraptor were around about 65 million years ago. So for some perspective, T-Rex and Velociraptor are closer in time to us today than T-Rex is close to these dinosaurs. Okay. So it's kind of crazy to think about, but these dinosaurs are really old. And then here you can see, this is a full-size Allosaurus. Like we talked about before, the bones that are kind of standing up like this, those are a cast replica because they're kind of in that dynamic pose. So that's made out of plastic. But this guy in the case, we're going to get a closer look at in just a minute. So Allosaurus had 3 fingers, huge claws that would have used to grab prey. We don't know if Allosaurus was a carnivore or a scavenger or a little bit of both. It's hard to really tell that just by looking at their fossils. There have been some theories about Allosaurus being like a pack hunter and all of that, but we simply don't know that for sure. So good questions coming up for sure. All right. Is there anything you guys would like to see while we're up on the wall still? No. Okay. So we're going to climb down the wall, take a closer look at that Allosaurus, and then we're going to leave some time left over for questions. So I know what I'm doing. Let's look at you guys. Because climbing down the wall is a little bit harder than climbing up. Okay. All right. And here you can get a closer look at this Allosaurus skull. So Allosaurus was the dominant predator of the Morrison time period. And this skull you're looking at is one of only 4 skulls of Allosaurus ever found anywhere in the world. The other one, the Allosaurus jamadsoni we looked at, is another one. So we have 2 of the 4 here in our collections. And this skull is definitely the most intact out of any of them, the best preserved. You can see held up by metal, so it's the real fossils, so you can tell that. And you can also see a couple of his teeth. He's obviously missing a few, but you can see his teeth there. And you can also see all of that gray stuff is glue, again, kind of holding that together. I know the glare is kind of hard on this angle, but I want you guys to see that because you can also see that hole right there is where a spinal cord would have gone in. So pretty incredible specimen right here. Yeah. Let me see what questions just came in. Can they unhinge their jaws? Yeah, hard to know for sure. And yeah, that sounds like Catherine answered that one, but good question. And so I think we're gonna just leave some time left over for questions. We're kind of running short on time. So I'm gonna flip the camera around and come on over here to our stand and open it up to you guys and see what other questions you have.
Yeah, if anybody wants, they can open up their mics or type it in the chat. And I'm just gonna ask you if you would to share again, because I had a lot of questions submitted, just wondering about your background, how you got into this position, and what your typical day is like.
Are you still there?
Yeah, I'm still here. I'm not quite sure what happened.
That was me. I hit the lock
Okay.
button on my iPad, so I apologize. Yeah, so that's a really common question. we get asked that a lot. So my degree's in environmental science. I went to college in Pennsylvania, really small liberal arts school called Juniata College that probably nobody's ever heard of because it's super small. But I got into the Park Service because I got an internship when I was in college. So I got an internship at Glacier National Park in Montana. And in my typical day in that sort of position was like leading people on guided hikes and doing ranger talks and kind of answering questions. It can be really fun to be a ranger and also really challenging because the questions you get, you have to have a really deep knowledge base of the topic you're talking about, and then be able to kind of translate that to whoever you're talking to. So you may be talking to people who have no knowledge of geology or have a doctorate in geology and kind of tailor where you're talking to based on your audience. So I wouldn't say I have a typical day, to be honest. I've worked at 4 different national parks. I've jumped around to many different places and parks. And my day is always a little bit different. Usually it's talking to the public and doing some kind of education, but that would be like the only consistency. Yeah.
We had a similar related question, which is, what is the hardest part of the job?
Yeah, the hardest part, you know, I've been a park ranger for about 12 years. So it's kind of in this spot where like nothing really surprises me anymore. This year has been really challenging as it has for everybody. But this year in particular has been kind of a challenging one. For example, about 5 minutes before we got on this call, I was kind of diffusing a situation where some visitors were arguing with each other about mask wearing. So there's been some weird conflicts there. So this year is probably one of the hardest that I've been a part of in my last 12 years with the Park Service.
And tell us a little bit about the staff of the park, if you would.
Yeah. So Dinosaur National Monument is like a medium-sized park. So we have about 80 employees in the summertime, and quite a bit less, so about half of that in the winter. So that includes everybody from like the education people, like we are here, and our division has probably about 15 staff. And then you also have like law enforcement, so essentially the police of the park. You have resources, who they're like the ologists, so to speak. So our paleontologists, our ecologists, our wildlife biologists. And then we also have like budget folks who are in charge of our budget and how we spend our money. And then we have people who are in charge of the river program. We're all there in charge of is like river rafting and helping folks do that safely. So it really varies widely. Some of the bigger parks especially have more people and more divisions. Some of the smaller parks have much smaller staff as well. So it kind of scales up and down based on how big the park is.
Well, and that actually feeds into my next question. We had somebody wondering where the funding comes from.
Yeah, so we're part of the executive branch of the government. So our funding comes directly from Congress. So that is can sometimes be challenging depending on like if a government shutdown is coming. That includes national parks. So that's always kind of interesting. So we're under the Department of the Interior, and we're basically a branch of the Department of the Interior.
And then there were some general questions about the park. Would you have any advice? So what do we need to be aware of to enjoy the park more? Should we manage to come in person someday?
Yeah. So I would say 90% of our visitors just come here. They just come to the Dinosaur Quarry, which is obviously an incredible resource and place to be. But Dinosaur National Monument has a lot to offer, and it's kind of, in my opinion, it's really a hidden gem of the park system. So everybody hears about Zion and Arches and Grand Canyon and all of these places, but there's some really incredible places here, and we haven't really been discovered. So we're not like overrun with 4 million visitors a year. Our annual visitation is a little less than 500,000 people a year.
And it looks like we got one question in chat now.
Yeah, let's check it out. Last time one of your fossils was sent to another site or museum. So that's kind of a little bit of a loaded question. So the initial excavation that happened here, we actually have not talked about this yet. So I'll do a quick overview. So this is just showing you the historic excavation. Okay. And I know this is kind of hard, but we're going to do our best here. So this is showing you how many fossils were actually excavated here. What you're looking at today is underneath the red line. Okay. So the fossils here today are about 1/4 of the fossils that used to be here. All of these fossils were sent to the Carnegie Museum in Pittsburgh, and then distributed to different museums around the country from there. And that happened from 1909 to 1924. And that's the last time we were like actively sending fossils away. Currently, the way that National Park works is if we excavate a fossil, it's ours to protect in perpetuity. So it's ours to keep track of. So it comes to our museum collections instead of going to a different museum. And then scientists come from all around the world to study fossils that are here. They also contact our paleontologist, like if they just need like a measurement or something, then she can do that for them and send off the measurement so they don't have to physically come here in person.
See, something says
okay,
we have
so the
mammoths.
bone wars, I saw we answered that.
Yeah. Do you have mammoths? We do have mammoths here in Washington State, but I'm guessing they were maybe asking about mammoths at Dinosaur National Park Monument.
Yeah, so short answer is no, we don't have that here. We have many different rock layers, but the most recent ones are from like the Cretaceous. So we're not finding deposits of mammoths here.
So about 63 million years before mammoths evolved.
Awesome. What other questions do you guys have?
Oh wait, we have a few. Oh yes. Oh, somebody's
feathers. Thank you. Good call. Okay, so yeah, what's the deal with the feathers? So dinosaurs. So just to like big picture, right? So birds that are here today, any birds you can think of, a chicken, a hummingbird, a penguin, they all evolved from dinosaurs. And specifically the theropods, which are the carnivore dinosaurs. So things that look like T-Rex and velociraptors. So any bird that you can think of came from dinosaurs. And so there's been some evidence lately that scientists have been studying fossil feathers. They're different from feathers you would think of on birds today. They're more like a single quill, kind of like a porcupine quill, instead of having like a shaft and then multiple feathers off of that. So just a way to think about it is like dinosaurs may have just been kind of fuzzy and potentially using their feathers for warmth or some kind of display mechanism. So feathers are not the only evidence of dinosaur bird evolution. There's quite a few other factors in like the skeletons of dinosaurs and traits that they share. Yeah. So thank you for the reminder. That was like a really quick version of how dinosaurs and birds are related, but that is the gist of it.
That's okay. We'll talk about it more in class, but it's good to hear about it multiple times.
Yeah, there have not been evidence of feathers here. And the reason for that, if you think of the river environment that was here, it's not a great place to preserve feathers, right? They're like really delicate. And we're thinking this big river just washing a bunch of bones downstream. We really don't find like delicate fossils here just because it's not the right environment to find them.
What do you think the chances are of another dinosaur species being discovered at Dinosaur National Monument?
Here, potentially pretty good. I mean, like I alluded to, our paleontologist is not doing excavations right now, but that doesn't mean it couldn't happen in the future. And because we have other rock layers here, it's definitely possible. Like, for example, we have the Cedar Mountain Formation, which has found, like, Utah raptor is a dinosaur that's been found there. We have that rock layer here. So it's possible that we could find more fossils than we have here today. Requires a little bit of luck and a lot of digging. Yeah. And yes, we only have one paleontologist. She hires interns every year, so if you're interested, that might be a good way to do that. But otherwise, yeah, we just have one paleontologist.
And that's pretty standard if there are fossils in the park for the people I've worked with, as I understand it. In most parts, I've worked with a lot of biologists, but very few paleontologists.
Yeah, yep. It's kind of a specific thing. So if there are fossils at a park, then they may or may not have a paleontologist. We also have a regional paleontologist, which means basically someone in like Denver who would be like an advisor for different parks.
And I know we're about out of time, but we appreciate the time that you've spent. This has been awesome. Yeah. Let's just finish up. I had several variations of a question, people wanting to know what they could touch in terms of fossils if they were to be there in person. Are there dinosaurs?
Yeah,
I think you showed us one.
So the Diplodocus is one of them. We can just like take a little, this big bone right here. This guy, this is a Diplodocus femur. So a long neck sauropod dinosaur femur. Most of the bones down here are from a Diplodocus. So you can see, I'll just turn you kind of this way. There's quite a few other bones here, and then most of them are from a Diplodocus. Yeah, so no spot, I saw a question just come in. There's some places that visitors can dig. That is a common question we get here. And we get a lot of disappointed kids, I can tell you that, because they show up and think that they're going to be able to dig. And because we don't have any active excavations, and also like visitors are not the best audience to have excavating fossils, we don't have visitors digging, even if we had some active digs. I know it's a bummer. There are places that you can either volunteer or pay to go dig that aren't a national park. That might be an easier way to do that. Our main job is preserving and protecting this for the future. So.
I would say let's thank you again. I'm going to stick around a little bit longer since there are some specific questions people had submitted about working as a paleontologist that I would answer. Thank you again. This has really been awesome.
Yeah, great. If really you guys have other questions that come up too, you can also email us, and we're certainly able to answer via email as well. So if something comes up later, that's what we're here for.
Will do. Thanks so much, Amanda.
All right. Thanks, guys. Hope to see you in person sometime.